Find the derivatives of the following 6 polynomial functions. During this video, we use the notation d by dx of f of x equals f dashed of x. We also rely on the following 4 rules. 1. That if c is a constant, then the derivative of c times f of x is c times the derivative of f of x, i.e. that we can pull a constant out of a derivative. 2. That the derivative of f of x plus g of x is the derivative of f of x plus the derivative of g of x. 3. That if r is a real number, then the derivative of x to the power r is r times x to the r minus 1. 4. That the derivative of a constant function c is 0. Problem 1. If y equals x plus 3, then dy by dx equals d by dx of x plus 3, which equals d by dx of x plus d by dx of 3, which follows from rule 2, and d by dx of x becomes 1 times x to the power 0 by rule 3, and d by dx of 3 becomes 0 by rule 4. And 1x to the power 0 plus 0 simplifies to 1 by the rules of powers. And so d by dx of x plus 3 equals 1. And in fact, we can write this result down immediately because we know that a line in the form y equals mx plus c has a gradient m. So that means that dy by dx equals m in such a case. Problem 2. If y equals 5x squared, then dy by dx equals d by dx of 5x squared, which equals 5 times d by dx of x squared, which follows from rule 1, and 5 times d by dx of x squared becomes 5 times 2x to the power 1 by rule 3, and that equals 10x. So the derivative of 5x squared is 10x. And usually we would just shorten this working and write dy by dx equals 5 times 2x, which equals 10x. Problem 3. If y equals 4x cubed minus 2x, then dy by dx equals d by dx of 4x cubed minus d by dx of 2x. And this follows from rule 2. And this follows from rule 2 even though we are subtracting two functions and not adding them. And we obtain 3 times 4x squared minus 2 by rules 3 and 4, which becomes 12x squared minus 2. So the derivative of 4x cubed minus 2x is 12x squared minus 2. In this problem, we have relied on rule 2, even though we are subtracting two functions rather than adding them. And we can show that we can do that as follows. If we have y equals f of x minus g of x, we can rewrite that as f of x plus minus 1 times g of x. And now we can apply rule 2. So we have that dy by dx equals f dashed of x plus d by dx of minus 1 times g of x, which becomes f dashed of x plus minus 1 times g dashed of x, which equals f dashed of x minus g of x. And so if y equals f of x minus g of x, then dy by dx equals f dashed of x minus g dashed of x. Problem 4. If y equals 7x squared minus 2x plus 1, then dy by dx equals d by dx of 7x squared minus d by dx of 2x plus d by dx of 1. And that follows by rule 2. And in fact, by rule 2, we can add and subtract any number of terms when we are differentiating. And now we apply the appropriate rules to each term to obtain 2 times 7x minus 2 plus 0, which simplifies to 14x minus 2. And so if y equals 7x squared minus 2x plus 1, then dy by dx equals 14x minus 2. Problem 5. If y equals minus 5 minus 5x plus 5x to the 4 minus 2x to the 7, then dy by dx equals d by dx of minus 5 minus d by dx of 5x plus d by dx of 5x to the 4 minus d by dx of 2x to the 7. And now we note that minus 5 is a constant, so its derivative is 0, and we ignore it henceforth. And by applying the rules to the remaining terms, we obtain minus 5 plus 20x cubed minus 14x to the 6. And you should note that the more rapid approach that I've taken here is closer to the way that we usually differentiate polynomials. We perform the working in our heads and write down the result. Problem 6. Y equals x times 3x squared plus x plus 2 over x. And we note here that in fact we don't yet have a polynomial, but we can obtain one by expanding the brackets. And if we do so, we obtain 3x cubed plus x squared plus 2. And we differentiate that expression as before to obtain 9x squared plus 2x.